Good evening, ladies and gentlemen, and welcome back to the Skywalk Podcast. We have a lot of great stories for you today, including our top stories of the week. A comet has been seen chasing its own tail. A dwarf planet has a ring around it that is honestly quite confusing and breaks a lot of what we know about science. And a moon mission is delayed, but still should be launching this year. Let's roll that intro. Hey everyone, how's it going? Welcome back. I just want to say off of the start here, as always, is just a big thank you guys for all the love and support on all the videos lately. Both the podcast and also all the YouTube short supplemental content has been doing very well. So I appreciate everyone, and I just want to express my thank you to you guys for all the love and support and the interactions, comments, likes, all that. Actually, especially the likes. There's been a lot of likes on the videos and shorts recently, and so I really appreciate that. You guys are doing awesome at helping with the whole algorithm, all that stuff, because they always want engagement and all that sort of thing. So you guys have been doing absolutely wonderful with that. I appreciate you guys, and it's showing me that you like the content. It's showing me to keep doing what I'm doing, and we're just going to stick with this for a little while until, I don't know, something new comes along. Speaking of possibly something new, though, so we have been doing the shorts content, and one thing that was actually brought up in, I believe it was the most recent short, was actually this thought that, how would you guys like, I'm just spitballing here, throwing out ideas, we're collectively doing a brainstorming session together, but how would you guys like to see, possibly shorts, maybe I could even do it in the podcast episodes, but little stories and snippets of how people see certain things in different cultures and religions. I know usually when we talk about our object of the week, I try to find any cultural significance to those objects, but I'm talking its own independent thing. Maybe we talk about the moon, and then specifically we say, okay, well, this religion sees the creation this way, this one sees it this way. In cultures, this is how they view the creation story, and so on and so forth. How would you guys like that? Let me know in the comments and whatnot, because I'll be interested in doing that. I always like learning about different people from around the world and how people view different things, even the same things. So I think that'll be really interesting. But let me know what you guys think. If you guys want to see that content, then I will go ahead and start making that. But I probably won't do it right now unless you guys really have that desire for it. And on top of that, in kind of the same realm of everything, what do you guys want to see? Do you have suggestions? I know that I go and research and make these shorts and podcast episodes, but if there is something that you guys want to see, if you have suggestions, please absolutely reach out, let me know, leave a comment, whatever you find easiest in order to share your thoughts. I would love to hear your suggestions. If there's an object that you want me to cover, if there are stories you want me to cover, if you want me to make a short about a certain topic, or if you want me to go more in depth about something. Like we vaguely mentioned black holes. And so if we mention that in an episode while we're talking about something, answering a question, do you guys want me to do an episode talking about black holes? Like all that sort of thing. If you guys have suggestions about anything with the content that we make, please reach out, let me know, because again, I want to cater to you guys just as much as obviously I'm trying to have fun with this as well. But if you guys have specific things that you want to hear about, then that is most important to me. So please let me know if you guys have any suggestions. But with all that being said, I feel like we're at a good point to just go ahead and get into today's episode. So like I said, welcome to the Skywalk Podcast. This is season 2, episode 5. My name is Gavin. I will be your host for today's episode. With all our introductions out of the way, it is now time for us to embark on our journey through the stars. So sit back, relax, get yourself a hot drink since it's been quite cool out and we're in February for those in the Northern Hemisphere. Get yourself a warm drink and a nice soft cookie. And as always, get those star cookies because those always get bonus points in my eyes. But let's jump into the space news. Our first story of the day is a comet that's been seen chasing its own tail. So this comet is called 69P Machholz. you know I'm bad at pronouncing things. Machholz. So yes, there's two H's in the middle there. But I'll probably just say Comet 69P because that makes it a little bit easier. This is a 6 kilometer in diameter comet, or that equals roughly 3.7 miles for those that use miles. And it's actually a really quick orbiting comet. The orbital period is 5.3 Earth years. So every roughly 5 years, it comes back around, which is kind of cool. It's not a super large comet, but it is a good size. Usually comets average around 10 kilometers in diameter. For example, I think, if I remember correctly, the Halley's Comet should be like, I think it's 10 by 8 by 8 in kilometers. So this is roughly 6 kilometers in diameter, close to that sort of size. So a good sized comet. And this recent observing was picked up by NASA's SOHO Observatory, which is SOHO stands for Solar and Heliosphere Observatory. It's a spacecraft that orbits Earth and it just stares at the sun. That's its whole job. And since comets are these icy bodies that orbit around the sun, that's when we start getting those tails, is when the comet gets close and the sun starts melting the comet a bit and leaves behind that cool streak in the sky behind it. But the interesting thing is that when they're observing it going around the sun, which they're observing for this portion, we're going to say January 29th to February 2nd of 2023, because you never know when people are going to listen to this episode. But when they're observing it going around the sun in that period, they're watching it, seeing the tail, seeing it interact with the sun, but then they actually notice that there was these particles in front of it that it was chasing after. These little bits and pieces that broke off and flew in front of it and is now in the same orbit. And so the comet is trying to chase after it a little bit. So it's actually pieces of the comet that is in front of it. And so you have the tail going backwards and these chunks of the comet in front of it, which is kind of weird. But while this may seem weird in the form of comets that we usually know that don't break off this easily and as frequently and chasing after it in front of it, this comet actually has this happen more often than not. Because since it's a very quick orbiting comet, we see it every 5-ish years, we've actually observed it in 2012 and 2017, and both times the same thing happened, where these little chunks were discovered in front of it that it was chasing after. Which is interesting. We're trying to, I don't know, just learn a little bit more about the comet, its composition. I believe it's actually a little bit of an odd composition for a comet itself, so scientists are interested in that. But we're gathering more information, and again, we're going to be able to see it really, really soon in space terms. And it's set to return in June of 2028. So, again, roughly 5 years from now, this comet should return, so who knows? Hopefully, we actually see these little chunks and the comet's chasing after itself again. It'll be kind of fun. But let's move on now to our second story of the day. A very confusing ring has been discovered around a dwarf planet. Specifically, it's been discovered around the dwarf planet, oh, here we go again, Quaoar? I'm just going to say Quaoar. I don't know how it's supposed to be pronounced, Quaoar. Again, I apologize for my bad pronunciation, but we're just going to stick with Quaoar to make it easier and faster in conversation. So the dwarf planet Quaoar. It's actually the 7th largest dwarf planet in our solar system. It's roughly 7, I can't really speak today apparently. It's roughly 1,121 kilometers or 697 miles in across. So it's actually a pretty decent sized object. That 700 miles is like, that's conceptually a very large portion of even the US if you're going across. The dwarf planet was discovered in 2002, and actually it's been seen to have one moon around it called Weywot, which is an awesome name for a moon, might I add. Weywot. I really hope it's pronounced Weywot because I think that is hilarious. I love that name so much. But it's now actually been discovered that it has a ring around it, but a ring that breaks physics. And so this ring was discovered during a session of occultations. to explain what an occultation is, well, things are orbiting in the sky and we have distant stars out there. And eventually, one of these objects, in this case Quar, will go in front of a distant star, preferably a brighter star. The brighter the better. And when it goes in front of it, it occults it, or almost you can think of it like an eclipse, and it blocks out some of that light, and then it goes away and that light from that star comes back. So it goes in front of it and blocks the light. And from this reading, you can learn different things about it. That's how actually Pluto was discovered to have an atmosphere, was occultations. And same with the discovery of the rings of Uranus, was all done in this sort of style. But in some recent occultation data, they've ruled out the means of interference from Earth's atmosphere or other means of interference. And what they noticed was something very peculiar. And that they noticed there was this ring system around the planet, because there was this dip in the brightness, and then the dip for the planet, and then another dip in the brightness. Meaning that there was that ring going around it. But the thing that's peculiar is how far away this ring is from the planet. The radius of this ring is almost 4,000 kilometers, from the center of this dwarf planet. I may use planet and dwarf planet interchangeably here, but it's a dwarf planet. And the radius is 3,885 kilometers, or that translates to 2,420 miles in radius, which is incredibly far for this dwarf planet, because they're not very big. They don't have a very big gravitational pull. And specifically, it is far enough away that this ring of little tiny dust material, bits, pieces, ice, rock, whatever, is actually so far away that it shouldn't be a ring. It should be far enough away that it actually forms back into another moon. And so this is a little peculiar, a little weird. And this actually a limit. There is a physical limit around a planet, a body of anything like that, but we'll stick with planets, including dwarf planets. There is this thing called the Roche limit, and this is a radius, a little disc, a visual disc around this planet or body, where anything inside of that limit will become a ring. It will be gravitationally ripped apart. Even if it was a moon and it moved inside of that circle, it would be shredded and ripped apart into pieces and form a ring. But anything that is outside of that ring, the gravity will mean that it will start to clump together and it will form into a ball. And for this limit, it is incredibly far away. It is really, really far outside of this Roche limit. Which begs the question of how. How does this dwarf planet have a ring that is breaking the boundary of physics for what is a moon and what is a ring that we know of? Something even more confusing is that the dwarf planet actually has two rings around it. It has a little gap in between the rings. It's like something like a two kilometer separated by a 5 kilometer gap, and then a 4 kilometer ring. But either way, it not only has one ring this far out, it has two sets of rings this far out of this Roche limit. Now, this begs the question of what do we do in this scenario? Assuming that this data is correct, which we are at this point assuming that these rings are actually there, scientists have two options. They either have to rethink and recalculate this Roche limit of where rings can form and how this process happens, or they have to figure out another explanation that keeps this limit boundary alive, but also explains how this dwarf planet mysteriously has these rings this far away. Who knows? Maybe we'll find out sometime soon. And our last story of this evening is that a robot mission to the moon has been delayed. But don't worry, it's not delayed by much, and you probably haven't even heard of this moon mission before. It's a robotic one. The Intuitive Machines IM-1, which I might just say IM-1, because that makes things easier, but the Intuitive Machines IM-1 is a mission that was set to launch relatively soon, within about a month, and go to the moon and land on the surface to do some things, which I'll talk about in just a second. But NASA convinced this company that was the one creating this lander to actually change their landing location. And now the lander is set to land in the southern pole, which is good because that's where the Artemis mission is planning to land, is the southern pole region of the moon. And so Intuitive Machines said, cool, I like it, let's do it, which means that it delayed the process a little bit because then I got to rework some things. It's been pushed back so that the landing will hopefully be in June of this year, 2023. So early to mid summertime, we should be getting this landing, while it was originally planned to happen sometime during the spring. The IM-1 is set to launch atop the spacecraft SpaceX Falcon 9 rocket, and this launch for the actual mission has been delayed from March. So originally it was supposed to launch next month at some point in March, but there's been no date. They just said it's going to be pushed back. They're hoping for a landing in June, and the logistics of when they're launching and getting there, all that sort of thing, hasn't been announced yet. So we don't know when it's going to launch, but they're hoping for it to land in June. This mission will actually prove to be a little bit of a scout mission for the Artemis missions. I feel like I'm saying missions so many times. But the Artemis mission is the next chance for NASA to land a man, not just a man, but woman and person of color on the moon, and that is supposed to happen in 2025. So in just about 2 years, we should have the next human landing on the moon, which is very exciting. But we want to see the terrain. We need to make sure that where we're landing is okay. And this lander, while it has other purposes to it, is also going to help scout the region a little bit as well. That's part of the reason why they wanted to change the location to the southern pole. It's also going to drop some NASA payload and perform a few different scientific tasks. I believe it has 5 different components on it that all testing out. But it's also going to test out and showcase its navigation system, its landing, and the communication system. So all different pieces of a good test, another just trying to build up this continual returning to the moon that is planned to happen starting this decade. But it's also part of a race, and the race is for the first privately funded moon landing. Up to this point, it's all been government public funding, but this is actually going to be privately funded, still by NASA, but privately funded with different funds, I believe is how I understood it. And it's racing against 2 different people right now. Astrobotic, which is a Pittsburgh, USA based company, and they're trying to bring NASA payload as well. And they are set to possibly launch sometime early this year. So roughly around the same time as this IM-1 is also trying to launch. The other company is iSpace, which is a Tokyo-based company, and they are trying to land in April. So they may actually have the best chance of being the first one now, is iSpace. They're trying to actually land with a rover that's been given to them to send over to the moon from the United Arab Emirates Space Agency. So it's going to be their rover that they're delivering to the moon. After this mission, though, if we're going back to IM-1 and if we're going back to the Intuitive Machines company, the original one we've been talking about, after this first mission, once they finally do actually land on the southern pole, there's already an IM-2 mission that is already being planned, and that's going to drop NASA Polar Resource Ice Miner Experiment 1. Sorry, I had to double check that because that's a very long name, but also called Prime 1. But some sort of mining experiment, which is kind of interesting. But IM-2 is scheduled to launch on the SpaceX Falcon 9 rocket sometime later this year, in late 2023. But that'll be it for our space news for this week. Hope you guys enjoyed these main topics for this week. It's kind of interesting ones. I liked it, especially that ring around that dwarf planet is when I read that and was trying to research it, it was really peculiar and interesting. And weird space things like that is really what got me into astronomy, is learning about just like, how does this make sense? And also, we have this law of physics of how things interact and how things do what they do, and something just broke it. And that's the kind of thing that I love. The astronomy and space science community, the field has been just exponentially growing with discoveries, and it's so cool. It's evolving so quickly. It's a really cool industry and place to be in right now. But with all of that said, why don't we move along to our object of the week? For today, we have another object, not just a star, and this time we have something called NGC 4755, which is also known as the Pirates Jewel Cluster. It's sometimes also known as the Jewel Box Cluster. It goes by a few names. It used to go by a different name that I won't repeat now because it's not as accepted and appreciated, that name for it now, but usually now it's something involving a jewel is the type of cluster. It was originally discovered in 1751 by Nicolas Louis de Lacaille, which is somebody that we actually talked about back in season 1, which is kind of cool. We're starting to see returning characters again, which is always nice. But the naming didn't come from him. The naming actually came for the jewel box. That's how I've seen it online more often, is jewel box. And that naming scheme came in the early 1800s by John Herschel, which we've talked about. William Herschel, he discovered so many things, was such an integral part in science and astronomy, but his son, John Herschel, was actually the one that named this one once he came up and started doing astronomy too. So that's just kind of cool. It runs in the family. But with all this, it is an NGC name. Usually, if something is a Messier object, we will use that name. That will trump the rest of the names. But in this case, Charles Messier is not part of the discovery. So alas, the Comet Fair will have to wait until another week, possibly. With a right ascension of 12 hours, 53 minutes, 42 seconds, the declination is going to be negative 60 degrees and 22 arc minutes. No arc seconds on this one. It is a very beautiful open star cluster. And what makes it interesting, and probably what we call this jewel box and whatnot, is a very predominant red star sitting right in the middle. But while there's this one really bright red star, there is actually a good few really bright and vibrant blue stars in it as well, which also makes it really pretty to look at. You can find this near this bright star called Mimosa, which is amazing star name, might I say, but in the constellation of Crux, which is the Southern Cross. If you've ever heard of that before, it literally just makes a cross in the sky. That's how, in the southern hemisphere, people are able to find the South Pole, because it points towards the southern pole. But if we have it on an angle here with the horizon down below us, the short part of the cross is going to go sideways, and the part that's pointing most eastward, most down and eastward on the short end of the cross is the star Mimosa, and it's right next to it. It's like just, depending on the orientation, it's like just down and to the left of the star, just outside of the cross, if that makes sense. But even though it is at a distance of just over 6,000 light years, 6,400 light years away, its apparent magnitude is only positive 4.2, so it's actually pretty bright. It can be seen with the naked eye. Assuming we don't have a very bright moon and you're in a relatively dark place, you can actually see this cluster. You'll see kind of a fuzzy gray patch in the sky near this Southern Cross, and you can actually just see without a telescope, which is really cool. I love objects that you don't need a telescope in order to see. It also kind of begs the question of how did Messier not see it, but we're not going to get into that one. But since it's a naked eye object, it means that all you would need to get any sort of real good detail out of it is a pair of binoculars or even a small telescope. It won't take much in order to make this object look good, especially since it's bright stars. It's going to look really nice very quickly. It's a very good object, especially for beginners. This would be a good one to practice actually trying to locate objects in the sky. get used to finding your, maybe not coordinates, but your reference stars and trying to find things that way, this would be a good one to deal with, especially if you're in the southern hemisphere. And like I mentioned, this is an open star cluster, which houses around 100 stars, just over 100 stars in this one. So it's not a very large open cluster, but it's a decent size. Usually they range in the realm of hundreds to maybe thousands, and so this is in the smaller end of open clusters, and it is kind of, you can notice it visually that it is a little bit smaller. But don't be fooled, because I mentioned those bright stars, this actually houses some of the brightest stars in the Milky Way. While they're very far away, so they don't seem bright to us, we can measure their luminosity and whatnot, and they're actually some of the brightest stars that exist in our galaxy. It's also going to be one of the youngest known open star clusters that we've ever discovered. The age of the Pirate's Jewel is only 14 million years old, which, again, human terms is a very long time. Yes, I understand that. But when we're talking about space and the universe being 13.8 billion years old, and most open clusters are in the realm of hundreds of millions of years old, saying that this cluster is only 14 million years old is really, really incredibly young, which is cool, which is really cool. The average radial velocity of the stars that are in this cluster as well is roughly minus 21 kilometers per second, or minus 14 miles per second, which it's velocity, so the minus sign just means it's going away from us. It's the difference between velocity and speed. Speed is just the magnitude, how much the number is, but velocity gives us that direction component as well. For anybody that's watched Despicable Me, you know exactly what I'm talking about. But the positive would mean it's coming towards us, negative means it's going away from us. But unfortunately, this one does not have any cultural representation that I was easily able to find, which is okay. Maybe somebody somewhere does have a story that's relating to this, since it's sort of a naked eye object, but nothing has to have a big cultural history to it, which is okay. Again, it's a newer object as well, so, and it's pretty small, so that could also contribute to it. I have actually been seeing this object. I'm in the northern hemisphere by a decent amount, which means that we don't really see this part of the sky too much. I honestly forget that we're able to see the Southern Cross at all, because it's also just not really high in the sky. We just get a little tiny glimpse of it going over the southern region of the sky, which means that this cluster is really only around for, like, I don't know, maybe we'll see it for a month or so. It's not going to be around for a very, very long time, because it doesn't go in the sky very high, so it doesn't last as long for us here in the northern hemisphere. But it is a very beautiful object to look at. I've seen it a few times. I actually just saw it yesterday, I believe, through a telescope, and it's very pretty. I can't really say anything bad about it. Before we move on to the Q&A, one thing I do want to mention about this object that we just talked about, I was mentioning radial velocity, and actually there's moving magic, you didn't see it, but I did double check because it sounded wrong when I was saying it. The negative radial velocity means it's actually coming towards us. So it's coming towards us at 21 kilometers a second, not going away from us. So I just want to make that correction there. I just did a live fact checking myself, so I apologize if people have already gone into the comments to correct me, but it is coming towards us. So I thought it sounded weird when I was saying it, so I wanted to double check. But with that said, and a little correction live during the episode like that, we can move on to our questions of the week. Our first question is very simple. Can life exist around a white dwarf star? For those that don't know, a white dwarf is the end stage of a star. It's kind of the ember that's left when an average star dies. So less explosion, more dissolving, and this is what our sun will do when it dies. It will leave behind a white dwarf star. It's star about clumped together about the size of Earth is how big it is. But going back to the question, the simple answer is, well, yes, it could. And I mean, I know that's a bit of a cop-out answer, is to just say, yeah, sure, it could, it's theory. But yes, it could. but it would be difficult, and it's honestly quite unlikely, at least in my perspective. The thing about white dwarfs is that they are, like I said, an ember. They're cooling off, which means that since they're cooling off, their temperature is getting less. That means the Goldilocks zone of where a planet can be, or where liquid water can form on the surface, is shrinking and shrinking and shrinking, getting closer to it. So if a planet is in the Goldilocks zone right now, in a certain amount of time, it may not be there anymore, which means that it could have started behind the Goldilocks zone too close, and then the Goldilocks zone is now within it. But all of that being said, it may not be able to sustain evolution like we had it here on Earth. And it just possibly couldn't have happened, but it also could have, because this cooling process, the shift of where that Goldilocks zone is like maybe tens of billions of years. So again, the Earth has not been around that long. It very well could have happened, but it's just going to be a little bit more difficult for things to evolve and form around a white dwarf like that. White dwarfs are also a little bit of a harsher condition to be around. They act a little bit different than regular stars, at least the regular stars like our sun. But one thing that also stumps me, that I think that means probably no, is that that star would have had to die, which means that that planet was far enough away that it didn't get eaten by the star, which also means that it's probably out of that Goldilocks zone by now, since the star is gone, or it's that white dwarf. But it also got rid of all that matter, and just that whole process of the star swelling and dying and whatnot could actually push the planet away from it. So again, it's kind of weird, because also maybe the white dwarf was sitting there and a rogue planet came in and caught itself around the white dwarf, is chilling in the Goldilocks zone, and now there's life. Yes, it could happen, but I'm going to err on the side of probably not likely. Our second question, all of these questions come from Reddit, by the way. Our second question is just simply asking, how easy is it to find a planet in the sky? And this is talking just naked eye looking up, how easy is it to spot a planet? And the answer is easy. It's very easy, and not like trick question like I did with the white dwarf. This actually is easy. All the planets, since our solar system is basically on a flat disk, all the planets orbiting in the same plane, which I believe the question actually originally mentioned that they understand that there was a plane, but didn't really understand the concept, blah, blah, blah. But solar system is flat. All the planets orbit along the same flat plane. Think of it like what's the word? I can't think of it. A plate, like a dinner plate. Which means that, from our perspective, all the planets will take the same path that the sun takes in the sky. This imaginary line through the sky is called the ecliptic. And the moon sort of follows the same path, but the moon is kind of above it and not fully accurate. But if you know roughly where the moon orbits in the sky, it's going to be semi in that direction. But more accurately, if you know where that ecliptic path that the sun takes in the sky, then that is where those planets will be orbiting. So look in that direction. If you generally know where the sun rises and sets, like is it more south, is it more north, or is it straight above you? Look that direction, and then look for the brightest things in that direction. Some of them will be stars, but usually planets will tend to be some of the brightest things in the sky, especially planets like Jupiter or Venus. They are going to be the brightest things in the sky. Venus is the third brightest thing in the sky, only beaten by the moon and the sun. And so if you see a bright star in that direction, the next thing to check, and the last thing to check, is it twinkling? A lot of you have probably heard Twinkle Twinkle Little Star, which is accurate, because if you look in the sky, you see stars twinkling. And that's because they're really far away. By the time the light gets to us, it's not as energetic and powerful, and the Earth distorts the waves a little bit. But planets are a lot closer to us, which means that the light is reflected back a lot stronger to us, and Earth's atmosphere isn't shaking it as much. Meaning that planets do not twinkle in the night sky. They are a static point of light. Now let's put all that together. You go outside, you know roughly where the sun goes in the sky, you look at the ecliptic, and then you see a bright star up there, and then you realize it's not twinkling, there is a very, very good chance that you have just spotted a planet without even needing to use anything. And also, depending on the planet, Mars will appear very red in the sky. Saturn will appear a little bit more yellow in the sky. So you can also see the color as well, depending on the planet. If you want an even easier way to find a planet, download an app. I always default whenever I can't find something in the sky, even though studying this, doing it as a hobby, doing it as a job, I still always have one of those apps on my phone to point the phone up to the sky and it shows you what's up there. So if you're ever not sure, that's a good way to double check. And our third and last question for today, are there solar systems and planets in intergalactic space? Specifically, the question was talking about, are there planets and solar systems in between galaxies? We know that there can be solar systems, rogue planets, and whatnot in galaxies, but can they be in the space between galaxies, in this kind of no man's land of empty space? And the answer is yes. While I don't know of any we've actually discovered, it does happen, and stars will be thrown into space. It sounds really violent, because it sort of is. Galaxies collide frequently. I won't say all the time, but they do happen, and we see galaxies colliding. And when this process happens, you can see animations, and these galaxies collide, and they end up throwing stars just out into intergalactic medium of just blank empty space. All those stars, chances are, on average, each star has one planet around them, meaning that they're just out there. But also, during this collision, while it's extremely rare, there are the chances that during this collision, two stars could get really close to each other in this whole chaotic ball, and then that ends up interfering with the orbit of the planets and throwing those planets out there, meaning that now there's just a planet floating outside of a galaxy with nothing around it, nothing in sight. It can happen. Again, we will probably never discover a planet or solar system like that because it is going to be so incredibly difficult, needle in a haystack for seeing the star in the solar system, let alone trying to see a planet around that. Yeah, good luck with our technology. But it happens. And then again, it happens in our own galaxy as well. That's rogue planets happen. They get separated from their solar system. So there's just loose planets floating in the Milky Way right now. With those questions answered, let's move on to our photo of the week. A very exciting photo, this one a little bit nearer and dearer to my heart. It's of comet C/2022 E3ZTF, also known as the Green Comet, the one that everyone's been talking about. I know I've done a few different things talking about it as well. But why this photo is being talked about is because it was done by a man called Dylan Short, who works at Lowell Observatory as a colleague of mine, and his photo was posted on Lowell Observatory's Instagram. So if you're interested in seeing this photo, you can go on to Lowell Observatory's Instagram. You'll see the comet photo there. I think it might be the second or third latest post at the time of recording this, and it's a very nice image. But why it sticks a little bit more to me, not only am I close with him, but this was during the closest approach. It was on Wednesday, February 1st. It was Wednesday night going into Thursday morning, and I was there. I was also taking photos with him. I haven't gone around to editing mine, which is a shame, and I will try to get through it, and I will show you guys that image once I finally do edit it. But he had more time and was able to edit his, and it came out absolutely incredible. He has a lot better equipment than I do as well, and so his image just looks stunning. And the reason it's so good as well, and why I'm interested in how good it is, because it wasn't done for very long. It was only about like an hour's worth of data, I believe, maybe a little bit over an hour's worth of data that both of us collected, and that's about it. You see a lot of these really cool photos that take hours or maybe many hours of data that's stacked together, but his was really around an hour, which was really cool. And it did take him about a day to process it. He texted me saying how frustrating the editing the comet photo is. So that's not making me very excited to edit mine, but his turned out incredible, so it's really worth the effort and struggle of trying to make it look as good as it does. So just wanted to throw that image in there. Very good job, Dylan. All right, guys, but I think that will do it for this episode of the Skywalk podcast. I appreciate you guys sticking around, for those that stick all the way to the end and watch all the way through. As always, I will throw out our social medias that we always talk about, and please keep interacting with the content, liking, commenting, even just throw an emoji in the comments. Your favorite emoji or your least favorite, I don't really care. Throw an emoji in there just to show that engagement so that we can continue to grow this podcast and all of the accompanying shorts and other content as well. But I appreciate everything that you guys do as well. And again, let's see. Who should we tell? Let's do the person that you would most likely send to the rings of Saturn. Whoever that is, go tell them about this podcast and tell them to go listen to it. Whoever you would most likely send to Saturn's rings. Don't know why I chose that, but that's what we're going with. But I think that's about everything that I have for you guys today. This has been the Skywalk Podcast, bringing you your weekly dose of space, news, and facts. You've all been wonderful listeners, and I will see all of you next week with another episode.